In this video, we're going to go over the concepts of the metric system, conversion factors, and dimensional analysis. We learned in the previous video that the metric system is a standard system of measurements. In addition, we saw how there are base units to describe the quantities that are utilized to measure matter and its behavior. So for example, the base unit for length in the metric system is the meter. A special feature that exists in the metric system is the use of prefixes. These prefixes can be placed in front of any base unit to increase or decrease its size by some factor of 10. In table 1.2, we can see a list of common prefixes of the metric system. Even though the list is more extensive, the only ones that you're responsible for knowing in this course are the ones that are included in the table 1.2. What you need to be familiar with is the name of the prefix, the abbreviation. Please make sure that you understand that some abbreviations are going to have capital letters and other ones are going to have small caps. And lastly, when it comes to abbreviations, specifically for micro, we're going to have a special symbol. So this U appearing symbol is the one that is utilized for micro, or micro can be symbolized by the letters MC. Next, we also have in this table the relationship between the power 10 or the factor of 10 to the base unit. And lastly, we have the same digit, but in exponential relationship or the exponential value. It is up to you if you want to memorize the regular notation number value for a prefix, or if you want to memorize the exponential one. It is all relative to your comfort. At the end of the day, you will see that we're going to apply these concepts specifically for when we have calculations to perform between two units. When it comes to units in general in science, because they are used to measure the same quantities, we must be able to interconvert between units. What this means is that we're going to have a series of equalities, which are known as conversion factors, that are going to use two different units to describe the same measured amount. We're going to see in an application that these equalities are going to be written as fractions when we are solving mathematical problems using dimensional analysis. And dimensional analysis is just a systematic mathematical method that we're going to utilize in order to convert from one unit to another. This is an important skill in science. There's many healthcare workers that need to be able to know how to perform these calculations in order to provide medication to patients. As you can see on the right side of the slide, this picture is illustrating a pharmacist that needs to calculate a dosage for medicine. The reason why this is important is because an error in unit conversion could mean that it's going to have specifically fatal repercussions to a patient. So you have to be really cautious and careful and learn this skill very well. I want to introduce to you a list of conversion factors. And in table 1.5, we have a list of commonly used conversion factors, specifically for the quantities of length, volume, mass, energy, and time. This table is going to be very useful whenever you're solving homework problems. We can see that the conversions include metric to metric conversions, English conversions, and even metric to English conversions. Because we're going to be using these conversion factors, specifically via dimensional analysis to interconvert from one unit to the next, I want to point out that conversion factors are actually exact numbers. What an exact number means is that it's going to be a number that have no uncertainty. And overall, what we're going to be observing is that when we use conversion factors in calculations, they do not limit the number of significant figures in the calculated answer. So what this means is that the final answer for the significant figures that need to be written in the final answer do not depend on the values that are present in the conversion factors. In exams, the following table is provided in order for you to perform conversions. At times, there will be problems in which we use one conversion factors. At times, there'll be problems in which we use more than one. That's why we're going to spend the rest of the chapter doing practice problems to solidify this skill. The first type of problem that we are going to be looking at is metric conversion practice. We can see that in the following problem, the problem reads, saline solution for intravenous infusion is used to treat dehydration and has a number of other important uses in medicine. A partial bag of saline solution has a mass of 615 grams. We're going to express that mass in kilograms and in milligrams. Whenever we're solving a conversion factor problem, we must write the amount that is given. And in this case, we have as a given measurement 615 grams. What the problem is asking us is taking those 615 grams. I'm going to write it twice because we have to do two conversions, and to change it into the units of kilograms, which that is the abbreviation for kilograms, kg, and to take those 615 grams and convert it to the unit of milligrams, which the abbreviation for milligrams is mg. I'm going to illustrate now how dimensional analysis can be utilized in order to get to the correct answer. You can observe that after writing what is the given amount and what is the unit that I want as our final result, I'm going to find in the tables that were shown previously, what are the different equalities that will take me from the given unit all the way to the needed unit. These amounts that you see here, so these conversions that we observed on the left side of the slides were obtained from the tables in the previous slides. So these are my conversion factors. To solve the first problem, I'm just going to rearrange some of the information that I already written. So it looks more neat. Now I'm going to write by dimensional analysis, how do I convert from grams to kilograms? Looking at my conversion factors, the one that relates kilograms to grams is right here. So I'm going to first write the amount given, 615 grams. In dimensional analysis, I'm going to take the equality, and then I'm going to write it as a fraction. When I take that equality and write it as a fraction, understand that what I'm doing overall is that I'm going to put the matching unit in the bottom of the fraction. So looking at the equality, what I'm going to write in the bottom of the fraction is 1,000 grams, because this is the unit that matches this. What I'm going to put on top of the fraction is going to be what that 1,000 grams equals to. 1 kilogram. So I'm just rewriting this part of my equality here, this part of my equality here, because this unit matches this. In dimensional analysis, units cancel diagonally. So by writing grams in the bottom part of my fraction, then I'm canceling the units of grams. Then, if I take my calculator and I multiply 615 times 1, and I divide the result of that multiplication by 1,000, then my calculator display will show me that the final answer is 0.615. As I mentioned before, because equalities, in other words, conversion factors, are exact numbers, what determines specifically the number of significant figures in the final answer is my starting measurement. 615 has 3 sig figs. 0.615 also has 3 sig figs. So I know that my answer is completed. Let's now proceed to specifically convert from 615 grams all the way to milligrams using dimensional analysis. First, I'm going to write down the amount given, 615 grams. And next, I'm going to take my equality that relates milligrams to grams. In this case, notice that when I'm writing this equality as a fraction, what matches this unit is the area of 1 gram. So I'm going to write in the bottom of the fraction 1 gram, and on the top of the fraction, I'm going to write what it equals to, 1,000 milligrams. Units cancel, as I mentioned, diagonally. So that means that grams cancels with grams. And when I take 615 and I multiply it by 1,000 and I divide everything by 1, my calculator display shows me that the value given is 615,000. Remember that the equality, meaning the conversion factor, does not determine the number of sig figs in my final answers. What determines the number of sig figs in the final answer is the measurement given. This measurement has 3 sig figs. 615,000 also has 3 sig figs. So there's no modifications that need to be done from beginning to end.